So this is my video on section 2.4, right? Okay, and in this video we are going to talk about uh, the official name for the 2.4 section is functions and their graphs. So we learned that a function can be represented in multiple ways. So like an arrow diagram, right? Okay, and then ordered pairs. So arrow diagrams is like that. Ordered pairs. So they are like 1, 2, 2, 3, and so on. And then graphs and equations. Graphs and for equations. So in 2.3 we kind of concentrated on the equations aspect of it, and 4.4 we are concentrating on the graph subset of it. So now if you look at most things in the universe, like a musical song is actually born through the building blocks do, re, mi, and a word in the English alphabet is born out of the letters A, B, C up to Z, right? Okay, and any number that you see actually is born out of the integers 0, 1, 2 up to 9. So for most things in the universe, like for example, periodic table, most chemical the compounds that we know are born out of the elements of the periodic table. So like that. So most things in the universe that you know are actually building blocks of smaller things. So for certain graphs that you use in college algebra often, right, you can actually find some building blocks. So one of the first things that we do in 2.5 is to identify these building blocks, and we call them parent functions because they actually give birth to other functions. So let's take them one by one. The first parent function is the familiar parabola. Okay, if you want to sketch that, right, what you do is y equals x squared, so x and y. You just take a few points, not too much because we are not in the business of sketching points anymore, but just a few points to guide it. Okay, so if you take 0, you get 0, 0, and if you put x equals 1, you get y equals 1. So x equals 1, y equals 1. And if you take negative 1 also, you get 1 because negative 1 squared is also positive 1. So negative 1 is also 1. And then if you put x equals 2, you get 2 squared, which is 4. And that's up. And if you put negative 2, again you get negative 2 squared, which is 4. So you can take the shape. So this is the first parent function that we know. And the second parent function that we are going to talk about is the sideways parabola, which is like this. For that one, we take only positive values of x because the domain is only positive numbers, right? Okay, and then what we are going to do is to pick some numbers. So we start with 1. So x equals, so we can start with 0. So if you put 0, then you get 0 square root, which is 0. And if you put 1, you get 1 square root, which is 1. So 1 goes to 1. And then we go to 4. Why did we go to 4 and not 2 and 3? Well, square roots of 2 and 3 are kind of decimal points and stuff like that. But square root of 4 is easy. So if you put 4 here, square root of 4 is 2. So that should be enough to for you to get an idea of the shape. So the shape will be like that. Okay, and then that's square root x. So you should memorize these shapes for these parent functions. And my third graph is x cube. So x squared is a parabola which goes like that. And actually, if you take x to the 4 and x to the 6 and x to the 8, all even powers, they look pretty much like x squared. But on the other hand, if you take the odd powers, x to the 3, x to the 5, x to the 7, they look pretty much like this curve of x cubed. So how do you get x cubed? Well, you can just plot points once again, x and y. So if you put 0, then 0 cube is 0. And if you put 1, you get 1 cube is 1. But on the other hand, if you put negative 1, you get negative 1 cube, which is negative 1. So negative 1 goes to negative 1, 0 goes to 0, 1 goes to 1. Right, and then it becomes steeper because if you put 2, you get 2 cube is equal to 8. So it goes steeper, right, and we get 8 here. So now you can see the shape of the graph x squared, x cube. The fourth graph we check is the absolute value function. What the absolute value function does is that no matter what you put as the input, positive or negative, it always gives the positive value. So if you put -5 here, you get +5. If you put -4, you get +4. But if you put +5, you get just +5. So how do you do that? So let's take some points. So 0 goes to 0 absolute value, which is 0. But if you take -1, you get -1 absolute value, which is +1. So -1 goes to +1. Okay. On the other hand, if you put 1, again you go to 1 absolute value, which is +1. If you put -2 absolute value, which is +2. So put +2, you get +2 absolute value, which is +2. So you get a graph which is symmetric to the y-axis. That's the absolute value graph. Okay. And so it's V-shaped. So it's basically the y equals x line, but reflected and then to the other side, and you get the same line on the other side. Okay. And then now we look at f of x equals 1 over x. So about this one, this is it's a fancy name called the rectangular hyperbola. But what it does is this. So if you take 1 over x, as x becomes very large, as x goes to infinity, what happens? When x goes to infinity, when x becomes very large, the fraction becomes very small and goes to 0. So that's why when x goes to infinity, the fraction goes to 0. The same thing happens if x goes to negative infinity. So negative infinity also, the function actually goes to 0. But now see what happens when x goes to 0. So if you take 1 over x and if you make x small and small and small and goes to 0, approach 0, not touch 0, then we can say that the 1 over the x becomes large and large and large. So that's why when x approaches 0, y goes to infinity. Whether you approach it from the left or from the right, y, well, if it goes right, then of course y would go to infinity with a negative sign, which is the negative infinity downwards. So this is another catalog operand function you should memorize. So now we get to this function, which has x with 2 brackets, and that's maybe a new function for most of you. We call it the greatest value function. Greatest integer, sorry, not greatest value, greatest integer function. So what is does is that now actually sometimes in programming languages there is a way of calling this the flow function, which sometimes actually makes more sense. Okay, so let's try to explain that. So if you take say 3.4, right? If let x equals 3.4, then f of x is 3.4 and the greatest integer function. What you want to look at is the result of the function output is actually the biggest integer, which is smaller than 3.4 or smaller than or equal to 3.4. So if you look at the integers which are smaller than equal to 3.4, there are lots of them, right? So -3, -2, 0, 1, 2, 3, all of them are actually smaller than or equal to 3.4, right? Not 4, right? But up to 3 is fine. So out of this lot, we select the biggest. Clearly, the biggest is 3. So the answer is 3. Another way of looking at this is you look down on the flow of the function and you select the closest integer behind it, not below it, not above like the ceiling. It's called ceiling function sometimes when you do it, look at above, but you look below. So when you look below 3.4, you see again 0, 1, 2, 3, and you select the biggest out of that, so 3.7. So if you take, for example, x equals 4.9 or something like that, right? And so you look at f of x. So once again, repeat that if you didn't. So if you put 3.4, you look down at the numbers below 3.4 and you select the biggest one, which is 3. But if you look at 4.9, once again, you look at the numbers which are below the 4.9. So what are those? So anything below 4.9 starts from 4 and then 3, 2, 1, 0. So out of these all of this, what is the biggest of them, which is 4? So if you take x equals 4.9, then fx, which is equal to 4.9 greatest value function, is equal to 4. So the greatest value function of 7.2 will be equal to 7. So will the greatest value function of 7.9. But if you take x equals, say, 5, what's the greatest value function? Well, when you look at all the numbers below 5, well, they are like 1, 2, 3, 4, 5, and so on, right? Okay, but up to 5. But what's the biggest number? Well, out of that, there's just 5. So how do you draw the graph of that? When you draw the graph of that, right? Okay. So here's what you do. So if you look at uh, say a number between 0 and 1, say zero point 0.5, then the biggest number below that is 0 or any number here. So for all the numbers up to 1, the number below the integer below that them is 0. So you map them to 0. So you get a flat line like that. But at 1, the number becomes 1. The greatest number below 1 is 1. So 1 gets mapped to 1. But all the way from 1 all the way up to 2, right? Right, 1.9999. And even if you take 1.99999 and then look at that and then look at what is the greatest integer below 1.99999, that will still be 1. But at 2, the greatest integer below 2 is no longer 1, it goes up. So you get a kind of a step function like that. All right, so that's the greatest integer function. So once again, our catalog has can be more functions, but we'll deal with these functions for the time being. The x squared like that, sideways parabola like that, x cubed like that, v like that, and then the rectangular hyperbola like that, okay, and then finally the greatest integer function like this, okay, which is a flow function which goes on like that. So thank you very much for watching this, right? And then I'll join you in another video, okay?